Hello and welcome back to Calculus 2. This is a review for exam 1 on chapter 6. In addition to that, you need to review the integration, which is spread through 4, 9, 5, 5, and 7, 1. Need to know how to do indefinite integrals, which means plus c, and definite integrals to compute integrals that have limits, which give you the number as the answer. The exam consists of, I believe, 9 sections of chapter 6 without 6.1, and we have area between two curves with associated formula, disk, washer, shell, arc length, surface revolution, physics problems, where if I have any of the physics problems that include physics formulas, I will provide those, but you are still required to do integrals and stuff. And then exponential and logarithmic functions redefined, where you integrate and differentiate exponential and logarithmic functions. And then you have the word problems. I said plus calculus because you have to either take the limit of the mathematical model to see if it's viable, long run, when you take limit to infinity, or you take the derivative to find instantaneous rate of change, or you take the integral to find the accumulation of whatever you're looking at. And the last is hyperbolic functions, which will definitely have 2 problems. One problem will be the proof of the identity. So one of those identities, I believe we did maybe 3 or 4 in class. That chart that has maybe 10 or so identities. So one from those will be on the test where you need to verify it by converting everything to e's. And then another calculus one where you either integrate or differentiate hyperbolic function. In case of inverse hyperbolic functions, I will give you those formulas because memorizing those, in addition to everything, gets to be a little bit much. But you must know all formulas, absolutely no formula sheet, and no graphing calculators. That is the rule at RVCC. Do you have any questions that we could look at, compute, have fun with? Yes. What happened? You have easy question. Okay, easy question, and then we have a scary question. Great, we'll do both. You can leave the garbage. Yeah, you can leave the garbage in the corner. Yes, Louis, you first. You got it? Okay. We just answered the first question by telepathy. The second question is the length of the curve for the function f of x, which is given as 3/4 x to the 4/3 minus 3/8 x to the 2/3 plus 7. From 1 to 27. We know the formula for length of the curve. The formula for length of the curve would be L equals integral a to b, which is our 1 and 27, square root of 1 plus the derivative squared dx. We first have to find the derivative of the problem, so copy constant, and then we have 4/3 x to the 1/3 minus 3/8 times 2/3 x to the negative 1/3, and then derivative of plus 7 is just 0. And this will all cancel. We have x to the 1/3 over here. Stuff cancels. We get minus 1/4, and then x to the 1/3 in denominator. Now we are going to use this in the integral. So 1 to 27 square root of 1 plus, and I now have x to the 1/3 minus 1 over 4 x to the 1/3 squared dx. The only thing we can do here is to square and hope we get that 1/2 in the middle so we can use the trick, right? So x to the 2/3, when you multiply these two cancel, 2 times yeah, there it is. Worked out nice. Plus 1 over 16 x to the 2/3, everything dx. I don't need this parenthesis. So now these two create a positive 1/2. Copy the rest, and this is where we realize that if these three with a negative 1/2 came from here, then these three that have positive 1/2 will be the same thing up there with the plus sign. So it's a nice trick that we use there. So this collapses into x to the 1/3 plus 1 over 4 x to the 1/3, everything square, where square and the square root die, and we have the integral 1/27 of x to the 1/3 plus 1 over 4 x to the 1/3 dx. Now integral for this, it's going to be, we get plus 1, right? So we have x to the 4/3 divided by 4, and then I put thirds. I put it up because the double fraction will eventually bring that up. Plus we copy 1/4, and we have x to the 2/3 divided by 2/3, because negative 1/3 plus 1 is positive 2/3. And then we have plus, oh no, we don't have plus c, we have the computation from 1 to 27. So now we simplify everything. We have 3/4 x to the 4/3 plus 3/8 x to the 2/3. Come on. Really? He decided to die. You observe over here, there's a little green sink thing, which is what I believe is the issue when it starts syncing with the cloud, and so these lecture notes are preserved. And if that misfires, I think it crashes the software. All right, so we plug in 27. So we have 3/4, 27 to 4/3 plus 3/8 to 27 to the 2/3 minus 3/4, and then 1 is just 1, and then minus 3/8. Now I'm going to use my tricks for quick computing. I'm not going to deal with 3/4. I'm just going to deal with 27. Cube root of 27 is 3. 3 to the 4th is 81. So this is 81. Plus 3/8. Cube root of 27 is 3 squared is 9. And then I have minus 3/4 and minus 3/8. And now I'm going to use algebra, where I look at these two terms and I factor 3/4. You can use calculator. So when I factor 3/4, I get 81 minus 1. And for the second pair, I factored positive 3/8, and I get 9 minus 1. So this is 80. So I have 3 times 80 over 4 plus 3 times 8 over 8. So this die, and this is 20. So the answer is 60 plus 3, 63. How you get it to type?
I put a mouse into it, and then.
And that's the mouse with only one button, right?
No. I use the real one.
Oh, you use the real mouse in that thing. Wow. The 3-button mouse.
I think actually
My mouse is 18 buttons. Yes. This is the easy problem, yes. This is the easy one, because the trick makes it quick. Yeah, quick. Chapter 7 is coming up. Also 8.5 is coming up. Yeah, this is quick. Yeah, you remember the integral test, right?
Oh, yeah.
You have to do 3 proofs, and then integral test you do all of this. And then you write a sentence conclusion. 8.5, coming up. Oh, of course. Should I? Right now? I don't know how far. All the way? Oh, infinite question. There we go. Length of the curve for the function. There on the interval. Yes, it came from the MyMathLab.
Study plan.
Study plan, yes. So it should be
Which one?
study plan. But it's one of the four, probably. Maybe we will replace it. Yes. Yeah, we can.
What kind of ticket? You gotta give me the number.
You have it? Bring it up. Ciao. What are we talking?
It's a little easier.
All right, so we have x equals y to the 4 over 4 plus 1 over 8y squared, 1 less than equal y less than equal than 5. Bueno. So this is one of the dy problems. The formula will still look the same. Now we have c to d, square root of 1 plus f prime squared of y dy. We find the derivative x prime, which is actually what we need, which is f of f prime of y, that's x prime. To find that derivative, we copy 1/4. The derivative of y to the 4 is 4y cubed. Remember, you're taking the derivative in respect to y, so you don't get to cancel. Plus 1 over 8. Y to the negative 2 becomes negative 2y to the negative 1. Now these guys cancel, these guys make a negative 4 in denominator. Oops. Negative 4 in denominator. So this thing becomes y cubed minus 1 over 4y. That's what we have. And now we feed that into the formula. I just need to indicate that this y over here spells dy, and then we know that's that formula there. So now we have the length of the curve is equal to the integral 1 to 5, those are the limits, square root of 1 plus, and we have to square y cubed minus 1 over 4y dy, and it's the same steps again. So we have the integral 1 to 5, square root of 1 plus y to the 6.
I think it should have been negative 3 instead of negative.
I'm sorry?
The derivative.
What do you mean?
Y to the negative 3 instead of negative 1.
Ooh, I integrated on that one. Oops. Yeah, I see now that it's not working, so I was wondering what happened. Okay, yes, thank you. I added 1 instead of subtracting 1. So -2 minus 1 is -3. Good thing I'm not taking the test. All right. Minus 1/2 because y cubed and y cubed will cancel, and then 2 times -1/4 is -1/2, and then plus 1 over 16 y to the 6. Thank you, Chris. Life saving over there. So the next step, again, we have our 1.5, which will add to positive, and we use the same trick of compressing it back. So 1 to 5 y to the 6 plus 1/2 plus 1 over 16 y to the 6 dy. Again, we are realizing that these guys came from the expansion of the one on top. We had the minus 1/2 and it had the minus in the parenthesis. Now we have the same numbers in the game except it's a plus, so it has to be this parenthesis with a plus. So we copy that parenthesis up there with the plus. We have integral 1 to 5 square root of open parenthesis y cubed minus 1 over 4y cubed squared dy, and this is where the square and the square root cancel, and we get just the integral 1 to 5 of y cubed minus 1/4 y to the -3 dy. Integration, we have y to the 4 over 4. No, this was supposed to be plus. Is anyone paying attention over here? And then 1/4 y to the -2 over -2, computed from 1 to 5. We can actually kick 1/4 outside and just have y to the 4 plus minus 1 over 2y squared from 1 to 5. Plug in 5, so that's 5 to the 4th, that's 625, minus 1 over 50, minus 1, minus and minus gives us plus 1/2. So this is our calculation that we need to work with. The great thing is 625 minus 1 is 624. 24 is divisible by 4, so we can reduce that. So we have 1/4 of 624, and now this is times 25, so 24 over 50. And this is great. So 4 into 6 goes once, 4 into 22 goes 5 times, 4 into 24 goes 6 times, plus 6 over 50. 6 over 50 is actually 3 over 25. So 156 plus 3 over 25. Now the trick is to write this as a mixed number, and you're done. You don't have to add this. Just write it as a mixed number, because 3/25 is a part of one whole. You have a number of whole pieces, and you know, if you want to get the complete fraction, you will just multiply it through, and 25 times 156 plus 3 divided by 25. Now, if you want to make it easier on yourself, you can actually multiply 78, right? You multiply 78 by 50, and that's easier, which is 78 times 5, and you add 0 at the end, and then plus 3. There are ways to compute much faster than multiplying by 25. You can divide by 2, multiply by 10. That's another thing. twice, because 25 is 5 times 5. Any other questions? These are very structured. We have rotation on X, rotation on Y, the difference between disk and a shell, area between two curves. You can't integrate that on a test. You have no means of integration, because integration of that is the trig substitution, and we didn't cover that. That's chapter 7. Sorry to disappoint, but I promise to include it on the next test, because that's a popular demand. Any other questions? Going once. Going twice. I will ask one more time before we close the deal. Are there any questions? Going third time. Did you say wait? Oh, okay. The question is coming. I'm excited. Oh, it makes me happy. Math problems. What does it say? Find the area of the surface generated. Oh, surface revolution. All right, so surface, let me just write it. Function y equals square root of 2x minus x squared on 3/4 less equal than x less equal than 1 3/4, and we have x-axis revolution. Good, thank you. So we're looking for surface area, and those guys are s equals 2 pi integral a to b f of x times the square root of 1 plus f prime squared of x dx. That's the formula. Again, you have to memorize this formula and use it, because that's Calc 2. Solving the integral is actually Calc 1. First we find the derivative. So f prime of x is going to be, we have the quotient rule, the chain rule over here, so 1/2 2x minus x squared to the negative 1/2 times the derivative of the inside. Now I can factor out 2, which will kill a half, and I have 1 minus x divided by square root of 2x minus x squared. So that will be the derivative. 1/2 is cancelled with the 2 that I factor. When I factor 2, you get 1 minus x, and then this entire thing is just the square root in denominator. Now we need to square this to plug in. So we have our surface area. So S equals 2 pi integral from 3/4 to 1 3/4. Now we have to write the function in. So that's 2x minus x squared times the square root of 1 plus, and I need to square this, which is 1 minus x squared divided by 2x minus x squared. When you square that, the root dies, and you have dx at the end. The only thing that you can do is to multiply these two, and that means that this inside of the root will multiply the inside of the other root, so this whole thing gets distributed here and gets distributed there. Now on the first one stays as is, on the second one it kills the denominator. So we have 2 pi integral 3/4 to 1 3/4, one large square root now, 2x minus x squared when we multiply by 1, and then plus 1 minus x everything squared, because these guys canceled. The only thing we can do is expand this one, combine like terms, and hope for the best. 2 pi 3/4, 1 3/4, and this is going to be 2x minus x squared. And now when I expand this, don't forget the middle term. So we have plus 1 minus 2x plus x squared. See that 2x? It's not there for decoration. It's the middle term. Ooh, that goes away, and that goes away. I know. I'm so excited. This is 2 pi integral of 3/4 to 1 3/4 the square root of 1 dx. Well, that's just x. So 2 pi x from 3/4 to 1 3/4. When you subtract 3/4 from 1 3/4, you just get 1. So the answer is 2 pi. Can you please plug that in, 2 pi? Did you plug in the answer? That
No.
we should have said fantastic. If you have the question from my math lab, you should always plug the number in. You said 2 pi? Still got it. After all these years. It's like riding a bike. What?
Can you scroll back up?
Yes. $2. You have to find the decimal for this. Did they say the decimal amount of thingy? Oh, okay. Use the mixed number then. You should have a thing. They change numbers? Yeah. How much did they change it?
What was it from? It was from, was it changed to, was it from 1 to 8?
Oh, yes. That's all.
Well, maybe I refresh it again, I'll go back to the
No, well, chances are slim, but if you refresh it enough times, within the infinity you will definitely guess it, but they might cycle it back too. Any other questions, concerns, anything? Not concerns, just questions. Math questions. That's the slice. That's how I forgot to mention that part was integrating the area on slice. Then post revolution is done in post like this in chapter 13. So yeah, they were there.
Your hand burns, I'm sorry.
You will not be forgiven. And I know your handwriting, so you're doomed on the test. All right.
These should be the same, right? 6 and 5. Some of them, so the same setup. No, they should be the same.
No, it's just the Apple thing. It's just, yeah. All right. We have another question. This is from 6.8, where we explored the derivatives and integrals of exponential functions, logarithmic functions. And we ran into the formula which we built up as we went along, right? We said that the integral of e to the x is e to the x, good. And then integral of b to the x is yeah. You just lost it. The derivative, yeah, no, the what's the integral? So this is what you guys have to work on then. See, that was a good question. Apparently, the whole classroom goes, no? So you have integral of e to the x dx. This is the basic one, right? You go e to the x plus c. And then you say, okay, what do I do if it's not, right? If it's a to the x, let's go b to the x for base. Well, it has to be the same as bx is the answer, but there has to be something else there to compensate for the difference between E and B. Ln what? No. Ln B. But then, it's not good to box that one. But then you say, but I want to have a function there, which means that it has to be a derivative here, so we can do u sub, and then we finally get that that's going to be b to f of x divided by ln b plus c. All right, back to original problem. So this is the boss equation over here. Back to the original problem. U equals sine 3t, du equals negative 3 cosine, oh wait, no. It's what the cosine 3t, that's the exponent, and integral is negative 3 sine, there we go, much better, 3t dt, and when we plug everything in, so what do I need? I need negative 3, right? So I'll put negative 3 in here, and put negative third outside. So now I have negative 1/3 outside of the integral, and inside I have b to the u du, and we can change the limits so we don't have to worry about stuff later. So when I plug in 0, cosine of 0 is 1, and when I plug in pi over 6, so pi over 6 and cancels is pi over 2, so this becomes a 0. Whoa. Larger number in the lower limit means swap them, but then we lose a negative on a third. And now we have the basic integral, which we can quickly solve. This is bu. Wait, why am I using b? It's 2. So integral is 2 to the u over ln 2. And we are computing from 0 to 1. So now 1 over 3 ln 2 is a constant. And we have 2 to the 1 minus 2 to the 0. Right? 2 to the 1 is 2. Minus 2 to the 0 is 1. So that's 1. And the answer should be 1 over 3 ln 2. What happened? We all good? du was in the part. All right. Ah, I still got it. Nice. Love it. I will upload these notes as a PDF, and the video will be available about 5 minutes after the class ends. Any other questions, concerns? Which one? Yes. U sub is ln x, and then 1 over x, and you have 6 to the u, which is the same problem.
Okay.
Very good. See you Monday. Any other questions? Going once. Going twice. And Everyone good? The ln x? Sure. I remember it.
You want to post the apple garbage?
Are there any limits on that thing or no?
1 to 4e.
1 to 4e, like this?
Yeah.
Huh. Cool. All right. I immediately see function derivative pair. There is a function ln x and there is 1 over x as its derivative, so we can use u sub, again, calc 1. ln x and du is 1 over x dx. Beautiful. I have that. So the problem is changed into 6 to the u du. All of this is du. And then ln x is u. So e to the u. Sorry, 6 to the u du. Now we change limits. 1 plugged in for x, we get ln of 1, which is 0. And when we plug in 4e, we have ln of 4e. We can split this into 2 ln 4 plus ln e, and this part is 1, so it's 1 plus ln 4. So that was a little transformation there. Now the integral of 6 to the u is 6u over ln 6, and the limits are 0 to 1 plus ln 4. Observe that I don't go back to x because I'm converting limits from x domain to u domain using substitution formula. You don't have to do that. You can solve the problem u and then go back to x and use the original limits, if that makes you sleep better at night. It makes me toss and turn more, so I always transform the limits. I have 1 over ln 6 as a constant, and then I have 6 to 1 plus ln 4 minus 6 to 0. Now 6 to 0 is 1, so you can't ignore it. Let's perform more witchcraft here. So ln 6, this is 6 to the 1 times 6 to the ln 4 minus 1. So we can do that, and that does not help at all. Yeah, this is going to be a decimal. Does it say type in a decimal to the some precision? Type an exact answer. So one of the forms of exact answer would be this one where you put 1 over here. I don't know which form they want, but that could be the form, this could be the form. We could write it also as well, I would write it as 6 to the 1 plus ln 4 minus 1 over ln 6. Maybe that's something that it's annoying to type in, especially in my MATLAB, and chances are that, you know, they might have a different form, so it's going to be marked as wrong. But maybe if you go and you reveal their answer at the end, you realize it's algebraically equivalent, at which point you know you have it right. Anything else? We can definitely squeeze one more problem if you have it. Did you click to see the answer so that you can see the form they used? Because the steps.
Hold on. Oh, yeah, that's right.
That's right?
Yes.
Any other questions? Oh, I forgot to check it. Last row. Anything else? Are you looking for another one? Cool. What does it say?
It says find the mass of the thin bar with the given density function. P of x equals 1 plus sine x is 0 to pi over 3.
So they're looking for mass of the thin bar and the density function, they use P of x, I use rho, doesn't matter, is 1 plus sine x. Mass is defined as the integral of density. So mass is going to be the integral of 1 plus sine x computed from 0 to pi over 3 by dx. The integral of 1 is x. The integral of sine x is negative cosine x. And we have to compute from 0 to pi over 3. We are going to put pi over 3 minus cosine of pi over 3 minus 0 plus cosine of 0. You see, you have to use cosine of 0 because it gives you a value. So pi over 3 minus cosine of pi over 3 is what? Very good. And then we have plus 1. So should be pi over 3 plus 1/2. Or 2 pi plus 3 over 6. Maybe this is the good form. Let's do another one because we can. It's free of charge. What happened?
Ooh, cool.
I was thinking to put this one on a test. Now you ruined it. You ruined it for everyone. Integrate 1 to root 3 secant hyperbolic of ln x over x dx. All right. So what do we have? We have a function derivative pair again, right? So what do we have to use? U sub, nice. So u equals, very good, du equals, great. So the question converts into secant hyperbolic u du. When I plug in 1, it turns into a 0. When I plug in root 3, it becomes ln root 3. What's the integral of secant hyperbolic u? Was there a square there on the question? Nope. All right. You don't know this one. No, secant square would be tangent. So if you're integrating secant square x, you're getting tangent x. If you are integrating secant x, you have ln secant plus tangent. Look it up. So now with the hyperbolic functions, it's pretty much the same. You still have the pairs working together. So secant hyperbolic u, what's the integral? So for regular trig, integral of secant squared is tangent. Integral of secant only, no square, integral of secant is ln of secant plus tangent. Yeah, hyperbolic plus tangent hyperbolic. So it should be that. Now this should be, can you please verify this one in the book?
Yeah.
In a,
I don't know about the hyperbolic.
all the way in the back you have the table of 106 integrals, and when you see the secant hyperbolic it should. Or if it's not there, then 6.10 at the end. But it doesn't have the password. Is that equivalent? That could be equivalent. Alright, kill it. Alright. Thank you. That was on page 495. What happened? U, yes. Thank you, U. Because we're going to plug this. So now this is tangent inverse. Well, thank you, Chris, for saving us here. And then we have sine, which is E, to the U, which is ln root 3, minus E to the minus ln root 3 over 2. Yeah. Minus tangent inverse of e to the 0 minus e to the 0 over 2. You can see that's 0 right away, right? Tangent inverse, ln e cancels, you get root 3, minus, goes as a, so it's 1 over root 3, everything over 2, minus tangent inverse of 0, which is also 0. So we have tangent inverse of, we multiply by root 3, and if I multiply by root 3 times root 3 is just 3, minus root 3 and 1 cancel over 1, and then 2 root 3, and then these guys will cancel because 3 minus 1 is 2. So you have tangent inverse of root 3 over 3, which is pi over 6. So if you plug in pi over 6 over there, should hopefully say fantastic. Does it say fantastic? He crashed? That is pi over 6. If we plug this in Wolfram Alpha, should say pi over 6. All right. I will upload these notes now to the website, and if I see you for office hours, I see you for office hours. If not, then see you Monday. Enjoy your